Now, for differentiating, it's really important that the equations are in a certain form. So they're going to be something x to the power of something plus or minus something x to the power of something, like this one here, for example, x squared plus 3x minus 3. Perfect for differentiating. Now, all of these are, except when you get down to this type of thing here, what you find is you need to expand this out first. So let's have a look at doing a few of those. Same here again, this is a perfect square. You're going to need to expand that out first. So let's have a look at how we would do that. So here we go. I'll just choose a few random ones. In fact, I'll just make up some, just as easy. All right. So let's just make some up. So let's imagine we're given, and by the way, you'll notice on this sheet here, this is from New Lake, these are all f of x as opposed to dy dx. So you'll be using the notation f prime x when you come to differentiate. Okay, so let's have a look at a few of these, or similar ones to these. So let's imagine I had y is equal to, and I'll just use y just for the sake of argument here. So I've got 2x times x plus 4. And I want to find dy dx. So my first job is to say, well, this is equal to, and I'm going to expand it out, 2x times x is going to be 2x squared. And 2x times 4 is going to be plus 8x. Now I can differentiate. So now I can go dy dx is equal to, or 2 times 2 is 4x plus 8, and I'm done. That's simple. Let's look at another one. Let's say we had f of x, this time I'll use f of x, is equal to x plus 3 all squared. Well, that is equal, of course, x plus 3 times x plus 3. I'm going to expand that out. Well, x times x is x squared. 3 times 3 is 9. And 3x is plus 6x. So now I can go ahead and say f prime x is 2 times that is 2x plus 6. And I'm done. Nice and simple. Let's do another one. Let's say I've got, in fact, I'll choose one of the ones they've got here because these are going to be probably a little bit better for doing, really. Yeah, they've got some great ones here. Look at these ones here. Look at this type of thing. And look at this type of thing here, or this type of thing here, yeah? So in this case, if you've got a function that looks like, say, this one, again, it's a little bit more to expand it out and multiply it out. But again, no problem. But you can just go ahead and do that. This type of thing here is a little bit different. Let's do number 37. So let's say I've got, and then I'll just rewrite that out. So you've got, let's have a look. So you've got f of x is 4. Oh, we can't see that, sorry. In fact, I can't even see that. 4x cubed plus 8. 4x cubed plus 8 on, and it's on x. So my first job, I must get it into the other form we discussed before. So I'm going to actually have to divide stuff by x. So if I divide this by x, in other words, it's going to equal 4x cubed on x plus 8 on x. Oh, sorry. What am I doing? 8 times x. 8 on x. So this is a slightly more challenging one, but I can divide this quite nicely because this is really x to the 1, and x cubed, 3 minus a 1 is a 2. So I can just cross out this and just write a 2 there, because x goes into x to the 1 goes into x to the 3, x to the squared times. So it's going to be 4x squared. Now, this is going to be, well, x, if an x is on the bottom, it's really a negative 1. So this is going to be plus 8x to the negative 1. So now I've got this in the correct form. I can go ahead and differentiate. So f prime x is equal to, well, 2 times 4 is 8x plus negative 1 times 8 is negative 1. So I'm going to put a negative 8 here. Now, I'm going to reduce the power by 1. If I've got negative 1 and I reduce it by 1, I'm really going minus 1 again, which is to the negative 2. So if I was now to write that out correctly, this is going to be 8x plus, I've got, or rather I should say minus, I'll just make it like this, here we go. So minus, I like this one, this is a very cool one, minus 8, but the x is to the negative 2. Or if I put it on the bottom, it's just x to the 2. And I've got all sorts of rubbish there as well. And that is my solution. That was a harder one, but just watch how I did it. I simply, first of all, divided the x's, so I end up with 4x squared. That was nice and easy. But here, this is really x to the 1. And if I bring it onto the top, the x becomes a negative 1. So I've got negative 1 times 8 is negative 8, which of course is, I can get rid of the plus there, because really the plus serves no purpose at that point. And now I've got my negative 8 on the front. I'm going to reduce the power by 1. Negative 1 reduced by 1 becomes negative 2, because negative 1 minus 1 is negative 2. And of course, x to the negative 2, the negative bit means just 1 over. So if I've got x to the negative, say, 5, the negative means 1 over. So it's literally 1 over x to the 5. Of course, if there was a number in front of there, that number would go on top here. So for example, let's say it was a 4x to the negative 5, that would become a 4 on x to the 5. The negative means over, so it's the reciprocal. And that is how I would solve that. And there's only one of those, or a couple of those. But do give those a shot. And I'll put the New Lake page up there for you as well. Please make sure you do them all. I'll post the answers shortly.